everyone, Joanna Wilson here for my OCR A-Level Chemistry Manual. Today we're going to be looking at Section 4 Physical Chemistry and we're focusing in on enthalpy. Just work, shoots are in. So our outcomes today are to be able to represent a reaction in terms of an energy diagram, to understand the terms exo and endothermic in terms of bond breaking and making, to understand the definition of different enthalpies and the conditions they apply in, and to know and use Hess's law to determine novel enthalpy changes that we cannot directly measure. So if we jump straight in, we know that energy is conserved in chemical reactions, and reactions also transfer energy. So an exothermic reaction is one that releases energy to its surroundings, so heat is produced, and an endothermic reaction absorbs energy from the surroundings, so it cools down. And the heat change corresponds to a temperature change as well. And we can represent this in an energy level diagram. So it's used to compare the energies of the reactants and the products so we can see whether the total energy change will be positive or negative. And that hump at the top is known as the activation energy, and that's the minimum energy required to start a reaction by the breaking of bonds. So as we can see, if the products are lower in energy than the reactants, energy is going to be given out and the reaction will be exothermic. If the products are higher in energy than the reactants, then it's going to be an endothermic reaction, and that's just summarized here on this slide. Bond enthalpy is an energy that's related to bonds, and it's when we break or make the bonds. Energy is either absorbed or released. So bond breaking is an endothermic process as energy is required to break the bonds. Bond making is exothermic as energy is released when the bonds are made and a more stable substance is formed. Please remember that this is the way around that these go. And the energy change for a reaction is equal to the difference between the energy absorbed by breaking the bonds and the energy released through bond making. So it's the breaking of the bonds and the making of the bonds that is important. So the definition of average bond enthalpy then is the energy change when 1 mole of bonds are broken in gaseous molecules, and the average bond enthalpy is what is tabulated and used in calculations of energy changes. And the actual bond enthalpy might be a little bit different to the average bond enthalpy, and whenever this comes up in an exam, you will be given the bond enthalpy values like so below in a table. You probably won't be given a table this big. It would only be for the bonds that you need to use in your calculations. So how do we work out these calculations? First thing we need to do is identify which bonds in the reactants break and find their bond enthalpies. Add the values up for the broken bonds. We then need to identify the new bonds that are formed in the products and list their negative bond enthalpies. Remember, we have to switch the sign for one or the other of the bond enthalpy values to find the energy released when the bonds are formed. Add up the bond enthalpy values from the formed product bonds and combine the total values for breaking and forming the bonds to get the enthalpy of reaction. And obviously, if this is positive, then the reaction is exothermic, and if it's negative, then the reaction is endothermic. Thank you so much for watching this teaser video for the OCR A-Level Chemistry Manual. You can now click the link download to download the full manual. Please check it out now. Keep smashing it, and remember, anything is possible if you just work. Bye.